Yeah, I guess we'll dive into this next one, longest digits prefix. Let's see what it's asking us. Okay, so we're given a string here. It's called input string, and we want to be outputting its longest prefix, which contains only digits. So this is a link. We'll click on it. String prefix. It's a substring of a string that starts at the first string's first character. Okay, a substring of a string is called a prefix if it starts at the string's first character. Substring. A substring of a string S is another string S prime that occurs in S. For example, fights is a substring of codefights, but cofi isn't. Okay, so we can't like pick and mix. They have to be all adjoining. So that's important. Okay, let's go back to string prefix. I like that. That's cool. Cool UI. All right, so a prefix basically is just starting at the beginning of the string. So if we're talking about this one, a prefix could be like this, just, 12. Or it could be 1, 2, 3, AA. That's a prefix. I think it could probably be the whole thing, as long as it includes the first character. It seems to match the definition here. It doesn't say that it can't include the last character. It doesn't have to be a strict substring or anything like that. So, okay, I mean, we're looking for basically just that beginning. Well, okay, we're going to take as many characters as we can from the beginning, as long as they're all digits. That's the idea. So let's do that. So again, we'll start with something pretty straightforward. We'll say let prefix just be that. And then we'll return prefix at the end of this. And in between, we're basically just going to say for let character of input string. So we're doing a for of loop here over a string. So character is just going to be each character of the string. And we'll do something like this. We'll say if 0 is less than or equal to character and character is less than or equal to 9, then prefix plus equals character. And otherwise, break. Now that's going to be a really important note here, the else break here, and I'll show you why in just a sec. But first, let's run this thing. Okay, so it's passing 4 out of 5 here. This one works, the 1, 2, 3, no problem. This one works from 0 to 9, no problem. But this one, not working. And that seems kind of strange, It does say always check for white spaces. So I guess, like we could throw in a little shim here and just say, okay, character is not equal to white space. All right, we'll see if that works. And yeah, okay, now they're all working. But I'm curious about that because it seems kind of strange, like the fact that the space character would actually be considered between 0 and 9 is a bit bizarre. If we look at our ASCII table, what we found is that 0 to 9 doesn't have space in between it. Space is actually the character code 32. So it's really strange, actually, that we're getting that result. So there is a reason for it, and it's kind of a sneaky one. It's basically this. Check it out. Return, and we're going to say space equals 0. This is basically the idea. It's saying, well, space is something that would get typecast to false, and 0 is also something that would get typecast to false. So because of that, they're considered the same. They are truly equal. Now, one thing to note is, I haven't really been using this, but we have a triple equal thing as well. And that's really, really similar to the double equal in the sense that it's making a comparison between two numbers or two variables in general. Except this one's returning false. So the reason is because when it's a triple equal, that is comparing them without any typecasting happening. We're not saying, would these get typecast to the same thing? We're saying, are they the same thing? Are they word for word, verbatim, the same exact thing? And so in this case, these are not the same thing. But it's because when we looked at it this way and when we're looking at this down here, that's kind of the way it's thinking about it. It does say, yeah, true. The thing is, this is a string, right? So the 1, the 2, the 3, yes, those are digits, but they're not numbers right now. They're strings. It's, the string 1, the string 2, the string 3. So let's now compare this to the string 0, and we'll see if the same comparison applies here. So no, actually, these are not the same because this is a string with a 0 in it. This is a string with a white space in it. They're not the same string. So a way to fix this problem without having to put in that and character is not with a space, we'll just do this. We'll compare them to the string 0 and the string 9 instead of the number 0, 9. Okay, so we'll see if this works. Hopefully it will. And great, it's passing all the sample tests, so let's give it a submit. We'll see if it passes all the hidden tests as well, and it does. Okay, great. So that feels good. We'll just wait for that to fly out, and let's try another strategy here. So this one worked. Oh, actually, sorry, before we go any further, I do want to take out the else break because I want to show you what would happen if we didn't break when we find something that's not a digit. So, okay, first of all, in some cases it would work. This one would be fine. All these other ones would not be, and we'll find out why that is. So in this case, we're getting not just the 1, 2, 3, we're getting 1, 2, 3, 1 because it's not stopping when it finds something that isn't a digit. It's just continuing, but just not doing anything with it. And then when it finds a digit again, it's putting it on the string. That's no good. It's not what we're looking for. Now, okay, I was wondering why this one was working, but I see why now. It's that it actually is returning the 3, but it should not be returning anything because there is no digit prefix here. Okay, 1, 2, and then the 3, 4. The output is 42. It's just getting the 42. Okay, so the only time that this would pass, and actually there wasn't a custom test for something like this. So let's say, 1, 2, 3, A, B, C, and we should get 1, 2, 3. And this one, yeah, that's better. Okay, so let's run the test on that one. And that one should be fine because it wasn't like there was anything else there. But anyway, these other 4 tests here illustrate the reason why we want to put the break in there. So keep in mind, break, as soon as a loop encounters break, it says, oh, okay, I'm out of here. And we basically just stop the loop. We don't do any more iterations. And that's different from if it were to say continue continue. If notice when I spell it right, it turns red. And the reason is because that's a keyword. It's just like break, except instead of saying stop the loop altogether, it says, oh, well, stop this iteration of the loop, but go on to the next one. And that's what it would do here anyway. So it's kind of like this isn't even there. So we'll switch that back to break. And now this should be working just like it was before. Great. So let's do something. Actually, you know what? Okay. Actually, you know what? Yeah, let's do something a little bit different. So I'm going to wrap this one up. And the reason I want to do this is because I'm going to take this and we'll simplify this even further. Because here's the thing. We're saying characters between 0 and 9. Really what we're trying to say is that character is a digit, right? So it's a string. When we're talking about a string and we want to look for some kind of pattern or some kind of property about the string, what are we going to use? We're going to use a regular expression. This is where we'll use a regular expression. It's when we're looking at a string and we want to try to tell some of its properties or something like that. So there are a few ways we could do this, but the way I want to do it is this. We'll say something like this, 0 to 9. So keep in mind, for a regular expression, we start with and end with a /. So now this is recognized as, well, just like for a string, how you start and end with a quotation mark, a regular expression starts and ends with a /. If you're not used to these things, it's definitely going to seem strange and out of place in the code, but it's totally legit. So then inside here, within these square brackets, we've got 0-9. That means as soon as you see the square brackets, it basically means it's going to match anything inside of there. So what we have there is equivalent to doing something like that. So it's just going through all the digits, except it's a little more efficient to just write it like that. So we'll do this .test on character. And that's basically saying, yeah, is it something that's 0 to 9? And if so, append it to the beginning of, or to the end of our prefix. Otherwise, break out of that loop. Okay, but since this is such a common thing that we want to know 0 to 9, there's a built-in for that. So it's \D, D for digit, I'm pretty sure. And we'll test that. And that should work exactly the same. So yeah, no major difference there. So that's pretty much the same as what we had below, except it's using a regular expression. Thing is, if we're going to be using a regular expression, we might as well get our money's worth. So we might as well let regular expressions do as much as they can for us. So here's what we're going to do. Let's say return, and we'll do our regular expressions, /d, and let's do this dot exec input string. Okay, we'll execute that first, and we'll see if we need to make any modifications from there. Okay, we do, because it's only saying 1 here. It's not giving us 1, 2, and 3. It's just giving us 1. So let's fix that by putting a plus. So a plus means it's going to look for 1 or more of those things, and by default it's going to be greedy. It's going to take the biggest one it can. So 1, 2, and 3, great. And notice it's not including the 1 over there. It's getting us our 1, 2, 3, but it's giving it to us in an array. And that's just a quirk of exec. And by the way, like, there's another way this whole thing could work. Like, we could say return input string dot match, and then do the same exact thing here, and it wouldn't work any differently. I mean, this is the same sort of thing. It's just that match is a string built in, exec is a regular expression built in, or method. So, okay, whichever one of those you prefer, it's up to you. I'll just go with exec for now. I think we used match last time. And then I'm putting in the @0 here because I don't want this to be in an array. I want the thing that's in that array. So we'll just execute that. And now, we are passing some of these things. So we're getting the 1, 2, 3. We're getting all of these. And we're not getting this one because we actually are matching that 3 there. So that's a bit of a problem. We're also not getting this one because we're matching the 42, and we shouldn't. Keep in mind, a prefix needs to contain the first character. So it needs to start at the start. Luckily for regular expressions, we have a character to represent that. So if we put in caret, now it's only going to match the things that start at the beginning. Okay, so now if I try to run this, on those 2 tests that it was failing, it's going to say, well, what do you mean? I can't give you property 0 of something that's an empty array. So that's why instead of just returning this, we're going to have to say, well, let's let matches be assigned the value of this. And then if matches.length is greater than 0, if there's actually some stuff in there, well then in that case, we'll return matches at 0. And otherwise, we'll return nothing. Yeah, I wonder if we even need to do that. Or by returning null, I wonder if that would sort of match the empty result it's looking for. Either way, we'll try running this one, and ooh, okay, so can't read property length of null. Okay, so here's the thing. I want to take a look at this, actually. I want to try just returning this thing. This thing we were calling matches just a second ago. And the reason I wanted to return this is because for those tests that it was failing before, so it's not just, that's my mistake. It's not just that it was coming up with an empty array when there's no match. It's just a null. It's just not even something. It's not an empty array, so we can't even say dot length. What we can say is if matches, if it even exists, right? So if it exists, then that means there must be some stuff in there. It must have a length of at least 1, so this is fine. If it doesn't exist, well, return an empty string. That's kind of what we're looking for there. Okay, great. So that's passing the hidden, it's passing the non-hidden test. Is it passing the hidden test? Let's find out. So we'll give that a run, and there we go. So 2 ways of doing this, or 2 main different ways of doing this. And we find that, if we want to use regular expressions, we can use them pretty heavy. We can get them to do a lot of the work for us. So that's nice. Now the question is this the only way to do this one? Maybe there's a different way. So I want to take a look at another method that's going to use regular expressions, but in a very different way from the way we use them here. So, I was afraid of that. Oh no. Okay, we're into the Whitespace characters now. So these have actually proven to be kind of a big problem in some of these cases. Maybe I'll just start writing and I'll sort this out if need be. But here's what we're gonna do. So we're gonna try to find basically the index of the first non-digit. Okay, so we're going to say, all right, let's assume it's all digits up to a certain point. And so let's find that point where it starts not being digits anymore. And we'll say that's going to be input string. Now, okay, remember, if we were to just do indexOf, this is a bit tough because what we want to say is the index of basically something that's not a digit, right? We just want to find the index of something that's not a digit. So for that, since we can't use a regular expression in indexOf, because we want to use a regular expression, right? Like we want to say something that's not a digit character. So we could say something like, A to Z and lowercase a to lowercase z. Maybe it's got open and close brackets, stuff like that. So we could go through all the possibilities, but really what we're looking for is something that's not a digit character. There's a built-in for that. It's this, capital D. Okay, so it's the opposite of lowercase d, capital D, backslash capital D. Okay, so we're looking for the index of that, but that's not going to work. Partly because I'm not returning anything, but also mainly because indexOf is not something that supports a regular expression. It's like, well, what are you talking about? So thankfully, we do have a method that supports a regular expression. It's one we've looked at before. It's called search. So now the idea is we want to search for the index of our first non-whitespace character. This one, it's telling us it's going to be at 3. And if we look at it, 0, 1, 2, 3. Yeah, that's where it is. Okay, so then that's pretty good. I guess what we could do in that case is, instead of returning the index, let's return input string dot slice. We'll take a slice of this thing. We'll basically just take everything up to the index, not including, because that's where it's no longer a digit character. So let's run that, and hopefully that'll work. Okay, so notice it's passing 5 out of the 6. Almost all of them are totally perfect, no problems, but this one has an issue. And this is maybe seeming a little strange. Now, the issue with this one is it's saying, well, I never did find one of those. I never found a non-digit character. So the index would basically be -1. And when we say 0 to -1, basically it's saying, okay, go in 1 from the left. Okay, so we kind of have to check for that. So we'll say, well, is index equal to -1? Actually, yeah, okay, we'll take a look at that in a sec. But is index equal to -1? If it's equal to -1, just give me the whole thing. Because if that's the case, that you didn't actually even find a character in here that was not a digit, if you couldn't even find one non-digit, well, then it's all digits. Return the whole thing. It is its own digit prefix. And if not, if you actually did find an index, if it wasn't -1, well, give me the slice. Give me what you were looking for. So let's run that. We'll see if that works. And yeah, it's passing all the sample tests here. In a sec, we'll see if it's passing the hidden test. But there's a reason why I use the triple equals here. Actually, well, there wasn't that much of a reason, but there's a reason I want to show you something about these, because we haven't really been using a lot of triple equals. It is something we'll probably get more in the habit of doing, because I've heard it's the better way of doing things. I don't know. You learn new things every day. That's the joy of learning, right? The joy of the journey and not the destination. Anyway, the point is, so looking at this one, the reason I wanted to use this illustrative example is because if I were to do this and run the tests on that, this would actually not work in this case over here because of the triple equal. Whereas if it was just the double equal, it would work because they would get typecast to the same thing. -1 equals the string -1, but -1 does not equals the string -1. So this would not work, whereas if I get rid of the stringiness, then it will work because now it, yeah, actually is -1. Okay, cool, so that's good. I think probably this is a bit better than this one up here. I think they're both cool in the sense that it's kind of like, this one looks for the biggest prefix that it can, and it returns that prefix if it can. This one does almost the opposite. It says, well, look for the first thing that's not that prefix and then just return everything that came before it. So the only case we need to, think of like an exception there is if it didn't find that index. Just like over here, we had to find the exception if it didn't have any digits to begin with in its prefix. So it's up to you. I mean, I guess whichever one you prefer. I think exec has better support than search though, which is why I say this one's probably better. But anyway, personal preference. So is it passing the hidden test? I can't remember if we checked that or not. We'll run it and yeah, okay, there we go. So, all right, that's going to be it for that one, I think. Let me know if you have any questions, comments, or concerns. You can click on, oh, look at that. The number's a palindrome, 3,553. That's always nice. Yeah, so click on that one if you want to take a look at the official JS the Game solution for this one. Lots of regular expression kind of stuff here, which I guess makes sense. Anytime we're looking at a problem and it's asking us to check some kind of characteristic about a string, it's probably going to be regular expression time. So, okay. I guess that's going to be it for now. We're going to end today's episode there. I guess